Okay, here's the last method for solving systems of equations. This is honestly my favorite. It's the easiest, I think, especially if your systems are set up in a certain way. So let's get to it. Before we actually go through anything, I want you to check this work here and kind of answer these questions. In what ways are CD and Micah's approaches similar? In what ways are they different? And are they valid? And which one do you prefer? Completely up to you. Answer those questions and then check back, type your answers in and check back when you're done. Okay, so if you took a minute to type this in, they both are using algebra instead of graphing, so that's what they've done similarly. Sadie used substitution like we did in the last lesson. Micah also used substitution, but he did a little changing things around first, so he just set them equal to each other. They are both valid approaches. This one's up to you. What do you prefer? Okay, so substitution and graphing aren't always convenient, depending on the way it's set up, especially if you end up with like a bunch of fractions. So when both equations are written in standard form, I like to use elimination. Okay, so standard form here, x plus y, 2x minus y. My x's and y's are on the same side. Now, a couple things to remember is we are going to compare these two systems and find a variable that might cancel. So I noticed that like x and 2x don't cancel each other out, but y and a minus y do. So I could simply add these two systems together to cancel my y's out. So x, or 1x plus 2x gives me 3x. My positive y and my negative y cancel, and then 7 plus 2 is 9. Now this is a really easy equation to solve. Divide by 3 on both sides and you get x equals 3. The only thing you need to be careful of is just because we're using a different method, that doesn't mean we could stop here. We still need to find our y value by taking this 3 and putting it into x here or here. So I'm going to go ahead and put in the top one, 3 plus y equals 7. Let's subtract 3 from both sides to get y equals 4. According to this, my answer should be 3, 4. Okay, you can check by plugging this into the second equation and making sure it works. So 2 times 3 is 6. 6 minus 4 is definitely 2. So that makes me really happy. There are examples online, so you can check those out. Also do the try it problems either using Realize or on page 158 in your book, and you can enter your answers in either place or both places. Okay. Next problem, notice now that x and 2x don't cancel and 3y and 2y also don't cancel. So I'm going to have to do an extra step before I can add these together. What I need to ask myself is if I have a 2 here, can I multiply this by something that'll cancel? I know that 2 and negative 2 cancel, so if I multiply this by negative 2, that should work. So I'm going to multiply everything in the equation. The most common mistakes are that people forget to multiply by something or they forget a sign. Okay, so negative 2 times x is negative 2x. Negative 2 times 3y is negative 6y. And negative 2 times 7 is negative 14. The second equation I'm not changing. Kept it the same. Now, notice that now I have a negative 2 and a 2. So if I add these together, they cancel. Negative 6 and 2 give me negative 4. Negative 14 and 6 give me negative 8. So divide by negative 4 on both sides, you get that y equals a positive 2. I'm going to take that y and plug it back into one of the original equations. So I'm going to just go ahead and go to the top equation, and I'm going to put a 2 in right here. So I have x plus 3 times 2 equals 7. 3 times 2 is 6. That's a plus sign there. And so if I subtract 6 from both sides, I get x equals 1. So my solution should be 1, 2. But I can also plug that into check by doing the second equation. So 2 times 1 plus 2 times 2 equals 6. xy, 2 plus 4 is definitely 6. It's been a long time. It's a good thing we're getting these right. Okay, do the try it problems either online and enter them there, or look in your book and do it that way and type them into a puzzle. Example 3, apply elimination. Okay, this is your 3.0 question. A florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? We are going to write an equation for roses and an equation for peonies. Okay, so the regular bouquet has 5 roses. So I'm going to call this X and I'm going to call this Y. So 5 roses and 11 peonies. The smaller, the mini bouquet, has 3 roses and 5 peonies. There's a total of 118 roses and a total of 226 peonies. This one is going to require even more work than the last one. Neither of these cancel. So to make this really simple, what you could do is take the leading coefficients and switch them. So multiply the top by 11 and the bottom by 5, or you could do the top by 5 and the bottom by 3. It is completely up to you. I like to use smaller numbers as possible, so I'm going to go ahead and do the second one I said. I'm going to take this 5 that's in front of my, that's a y there, not a p, a 5 that's in front of my y, and multiply that by this first equation. I'm going to take the 3 that's in front of my y and multiply by the second equation. So 25x plus 15y equals 118 times 5, which is 590. And then 3 times 11, so 33x plus 15y equals 226 times 3. So I get 678. Here's my problem. Right now, these do not cancel because they're both positive. So what I'm actually going to do, and you can actually do this in the first step, is I'm going to change the signs for every part of that first equation. So now I do have a negative there. So negative 25x plus 33x is 8x. Negative 15 and 15 cancel. And 678 and negative 590 give me positive 88. So if I divide by 8 on both sides, I get x equals 11. We still need to go plug that in to figure out y. So we're going to go ahead and do that. We're going to do 25. Actually, I'm going to go to the beginning. I'm going to use that first equation. So 5 times 11 plus 3 times y equals 118. So 55 plus 3y equals 118. Subtract 55 from both sides. 63. Divide everything by 3, and I get 21. So she can make 11 regular bouquets. Let's see if I spell it correctly. And 21 mini bouquets. Okay, check that by plugging it in here and multiplying it out to make sure it works. Okay, when you are doing these on your assessments, we don't actually care which method you do unless, as long as you can do it correctly. Okay, so choosing a method, actually I'll go back to that. The only time I actually choose to graph is when they're both in slope-intercept form and they cross at a nice easy point. The only time I use substitution is if one equation or both equations is solved for x or y. And then elimination I like to do when my x's and y's are lined up. So notice this first one, since the y is alone already, I'm going to just use substitution because I don't have to do any extra work to get started. And I'm going to solve by distributing. So 7 times 13 is 91. So combining like terms, subtract 91, you get 9x equals negative 81. So x is negative 9. I'm going to plug that back in here to get negative 9 plus 13, which is 4. Make sure you write your answer as an ordered pair for your final solution. For the second one, my x's and y's are lined up, so I like to use elimination here, but nothing cancels right now. So the first strategy I told you could try is to multiply the top one by 5, the bottom one by 8, and then change your signs so they cancel. But I also noticed that this 2 goes into 4 twice. So I could just multiply that top equation by 2 to get 16x minus 4y equals negative 16. The problem is that my negative 4y's don't cancel, so I'm going to go ahead and do what I did in the last problem and change all my signs. so that I can actually cancel my positive 4y and negative 4y now. So if I add those together, I get negative 11x equals 33. So x is negative 3. We can plug that back in. So 8 times negative 3 minus 2y equals negative 8. I add 24 to both sides. I'm running out of room here. Don't drop your negative sign, that'll mess you up. So 2y equals negative 8 plus 24, which is 16. Divide by negative 2 to get y equals negative 8. So negative 3, negative 8 is my final solution. Okay, again, try it problems. If you're good, you're good. Move on. Here's your practice. You can do it online or you can use the online book. Completely up to you. The lesson quiz is just to see how you're doing on this topic. It will actually not count to your grade. If you have any questions, let me know. Have a great day.